Hello guys, welcome to my channel. In the last video I talked about the Numpy arrays and I gave brief information about the Numpy arrays, also the main differences between Python lists. In today's video I will be implementing the Numpy arrays and it's going to be the first video on Numpy implementation. So let's get started. So first you have to import the Numpy library. If you don't have it already installed on your PC, you can download it from your command prompt or directly from your Jupyter notebook. So you can write pip install numpy. I already have it installed on my PC, that's why I will not use. So I will directly import the library, and every time I don't want to write numpy, it's because very boring. Instead I will write np, so I will use the np abbreviation for numpy. So first I want to create any list, for example, maybe the first 5 integers, and I want to check the length of this list, and I want to convert it into a numpy array. So first method to create a numpy array is first you can create a list and then you can convert it into a numpy array. But as I mentioned in the previous video, numpy arrays should be the same data type. But here all elements are integers, but we can have lists containing different data types. But here it's valid, so all 5 elements are integers. So I want to convert it into numpy array. So you write the np. From the np model you insert array function, and inside the array function you write the list. I'm sorry, I have to plug my computer. And voila, we have created our numpy array, and I want to check my array. And there are different methods and attributes of numpy arrays. For example, first of all, I want to check the dimension of the array. So dimension is one-dimensional array. So I will create the numpy array in this method. So I will not use the list first. I can write like this instead, and I want to assign the data type. If you have the integers not big numbers, if they are small numbers, you can use np16 or np32. If you have very big integer numbers, you can use np64. So the type is equal to np int 16, or you can use this way, it's the same. And I want to check the d type. Yep. And maybe later I decided to increase, change the numbers, like not small integers, very big integers I want to use, and I want to change the data type from integer 16 to integer 32. Then I don't need to rewrite everything from the beginning. I can just use the method of numpy arrays, and I can reassign it to the array is array as type, and I want to use np int 32, and I want to check the d type. Yep, it has converted the d type into integer 32. And now I want to know other parameters of the arrays. For example, array shape it's one dimensional. It has 5 elements. Maybe array size. I have 5 elements in the array. I want to know how many bytes each element takes in my array, so I can do that. Item size, it shows the memory for one element. It's 4 bytes because I converted the data type into integer 32. In 1 byte we know that there are 8 bits. That's why one element takes 4 bytes. But in the previous case I said we have small numbers, that's why I can use integer 16 and it only takes 2 bytes, which means the second data type takes more memory. That's why I recommend you to use integer 16 if you work with small numbers. Of course it will not make any problem if you work small arrays, but in computations there are the arrays containing even hundreds of thousands of data elements. That's why in this case it will take a lot of memory. That's why so you have to be very careful with the data types and the memory. And then I want to know the total bytes, so I can check that in 2 ways. I can write the item size multiplied by the array dot item size, and here if I press the tab I can see item size, and I can check 20 bytes in total. So there are 20 bytes in my array, but I can do that in a better way. There's a functionality for us and it directly says that 20 bytes is a memory that our array takes in the storage. What else? I think that that's already enough for the simple parameters. Now I want to create more dimensions than one. For example, I want to create a 2-dimensional array. For example, np.array 1 2 3 4 5 6 and 7 8 9, and then array and array in dim. You see it's 2-dimensional array, and 1 2 3 you can see 3 rows and 3 columns. It's always better to write in this way, np.array. First you write the first one, because it's better to see the dimensions, because when you work with the arrays that have more dimensions than 2 3 it will be very hard for you to see what's going on in the dimensions. That's why it's more recommended to use the Numpy arrays, to implement Numpy arrays in that way. And it's the same thing, and we can check the dimension and it's still 2-dimensional, and we can increase the number of dimensions, and but 2-dimensional is usually enough because we usually work with the tabular data sets like pandas, data frames, and they are in a tabular form. That's why the tabular forms are usually in 2-dimensional cases. In the next video I will be talking about the indexing. Indexing is very important topic in data science, in data analysis, and different fields of data analysis. So that's it for this video. Thank you so much. If you like the video, press the like button and subscribe.